Algebra now focuses on variables. Sometimes these are known, like let's say x is equal to 3. If we go to our Cartesian plot, we have our x-axis and our y-axis. X is equal to 3. No matter what y value, x is always 3, so this is never changing. We could have y is equal to 2. Takes us up here, and it's the same sort of flow. So now we have a horizontal line instead of a vertical. Sometimes there's a relationship between variables. For instance, if y is equal to x, no matter what value we plug in for y, we always get the same value for x. We can make it a little more complicated. Y is equal to x plus 3. And now whatever value of x we put in, we add 3 to that, and we get our y value. We could say y is equal to a function of x, and that function is x plus 3. Now when working with this, we will say we can, to graph this, we want to typically just pick out 2 points. So we could say let's do x is equal to 0. That leaves us with y is equal to 0 plus 3, which is equal to 3. And that gives us the point 0, 3. And then we could also say, well, x is equal to negative 3, and that gives us y is equal to negative 3 plus 3, or 0, and that gives us the point negative 3, 0. To graph it, we just take those 2 points, negative 3, 0, and 0, 3, make our Cartesian plot. We have negative 3, 0 here, and 0, 3 here. We just draw a line, and it goes on forever, this line, because it's a constant growing graph. It just goes on forever. A more complicated example could be like y is equal to 2x minus 6, for example. So the first thing we would want to do is let's let y equal 0 in this. So now we get 2x minus 6 is equal to 0. 2x is equal to 6, or x is equal to 3. And that gives us the point 3, 0. We could also set x is equal to 0, which gives us y is equal to 2 times 0 minus 6, or negative 6, which gives us the point 0, negative 6. And to plot that, this isn't to scale, this is, let's say this is 0, negative 6, and we had 3, 0. Imagine that's a straight line. A little better. Sometimes in algebra, we want to oscillate one variable instead of the other. So in this instance, if we want to solve for x, we just say y minus 3 is equal to x. We just add negative 3 or subtract 3, whatever you want to say. In the other example, y is equal to 2x minus 6. It's the same sort of idea. We solve for x, so we want to isolate for x. Just add 6 and then just divide the 2 out. Which gives y over 2 plus 3 is equal to x. And that's pretty much it for the linear graphs that I'm going to go over. I'm going to go over some more stuff later in future videos.